Okay, these are the U substitution problems. These are from 6-8. I'll just write the numbers down here at the top. 5, 11, 13, 15, 29, 33, 35, 37, and 45. I'm going to work through them pretty fast here to try to keep this video a reasonable length. So please be prepared to do lots of pausing and picking up of things as you need to. Okay? Number 5, the integral from 0 to 1, 2x plus 1 to the third dx. So u looks like it should be 2x plus 1. This du is 2 dx. I don't have a 2 in there, so if I put a 2 in here, I have to put a 1/2 out there to balance that. So now I have 1/2 times the integral. I'm going to change over to u numbers, plug in 0 here, and it gives me 1. Plug in 1 here, gives me 3. And that's u cubed du. And now I can use fundamental theorem of calculus part 2. So that's u to the 4th over 4, 1 to 3. So I'm going to move that to the outside. I think that makes things easier. So 1/8. 3 to the 4th is 81. 1 to the 4th is 1. So 1/8 of 80 is 10. You might keep in mind that tomorrow on the quiz, or whenever you're watching this video, the quiz that you're going to have to take where you have to do this, you need to be able to do these fairly quickly. So I think part of studying is practicing and trying to get so you can do things at a reasonable speed. So the what's inside looks like here it should just be x over 2. That's the same as 1/2 x. So du would just be 1/2 dx. That means I need a 1/2 here. I need a 2 on the outside. And oh, by the way, I don't want this in here, so I'm going to move that to the outside also. So that turns into 8. That's my 2 here and this 4. And my new numbers, 0 divided by 2 is 0. Pi over 2 divided by 2 is pi over 4. And I now have sine of u du. So that's equal to 8 times the, oops, sorry, I think I'm going to take my antiderivative now. Antiderivative of sine is negative cosine u, 0 to pi over 4. So I've got 8 times the, I'm going to take the negative sign out because that's just confusing. Too many negative signs in there. So cosine of minus cosine of, and that gives me 8 minus the square, 4 square roots of 2. Right? Okay. I suppose I should check these in the back, but maybe I'll do that at the end. So if I miss one of these, it's only because I'm careless, moving too fast. But I'll check at the end and try to fix any mistakes. So let's see. We have negative 2 to negative 1, x over x squared plus 2 cubed dx. So it looks like the u wants to be the what's inside. It usually does. Usually. So du is equal to 2x dx. 2x dx. I need a 2 in there, so I'll put a 1/2 on the outside. So I've got 1/2. My new u numbers. Negative 2 squared is 4 plus 2 is 6. Negative 1 squared is 1 plus 2 is 3. And then on the inside, it's like I have u to the negative 3 du. Definitely like it better written like that. Fundamental theorem. Antiderivative of u to the negative 3. So the exponent goes up by 1. Be careful, right? That's from negative 3 up 1. Then divide by the new exponent. And then There's a couple things you could do here. You could use the negative sign to flip these, since these kind of seem like they're in the wrong order, right? Or you could just take the negative sign out and then deal with this, but however you want to do that. So I'll just leave the negative sign with this, take it out as negative 1/4, and then I have 3 to the minus 2 minus 6 to the minus 2. And let's see if we can simplify that. That would be the same as negative 1/4 times common denominator would be 36. That is 3 over 36, or 1/12 times, so that's negative 1 over 48. That's a wee tiny little bit of area there, isn't it? Little tiny bit of area below the x-axis. All right. Uh-oh, there goes my sheet with the right numbers on it. What do we just do? 13, so next is 15. Number 15, I have to go from negative natural log 3 to natural log 3 of e to the x over e to the x plus 4 dx. This one might take a little bit of messing around with, I suppose, but it turns out the right u is the bottom of this. Then du is just e to the x dx. There it is. So my new u numbers, e to the natural log 3 is just 3. Now this is the tricky one. E to the negative natural log 3. E to the negative natural log 3. It's not negative 3. If you want to use the rule that says e to the natural log of something is just the something, in other words, e to the natural log of a number is just that number, that's true. But there can't be anything in between here, right? And there is here. So this I have to bring in here. So that's the same as e to the natural log of 3 to the negative 1, or in other words, 1/3. And so it's 1/3 on the bottom. I think that's one of the trickier parts of that problem. And then what do we have? I've got 1 over u du when I make the substitution. The antiderivative of 1 over u to the negative 1, that's the only time we can't use the reverse power rule. It is natural log u, 1/3 to 3. That's natural log 3 minus natural log, oh wait a minute, oh geez, sorry, I forgot to add my 4 here, didn't I? So that's 7, and this is, let's see, 1/3 plus 4, it's 4 1/3, or 13/3. Sorry about that. So that's going to change things in a not so nice way. So it's natural log 7 minus the natural log of 13/3. If you wanted to, this is subtraction, so that's the same as the natural log of 7 over 13/3, which is the natural log dividing by a fraction, same as multiplying by the reciprocal. So that would be the same as that. I don't know what they have I bet they have that in the back. Next, 29. We've got square root of 2x minus 1, 1 to 5. So I'm going to try to do u is equal to 2x minus 1, so du is equal to 2 dx. Need a 2 there and a 1/2 on the outside. Jeez, doing that all day today. Saying one number and writing a different one. So 1/2, my new u numbers, plugging 1 in here, 2 minus 1 is still 1, and then 5 minus 1 is 9. Nice for square roots. And then this is going to be 1 over the square root of u, or u to the negative 1/2 du. And the antiderivative of that, bump the exponent up by 1, and then divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2. The 2 and the 1/2 cancel out, so I have u to the 1/2. 9 to the 1/2 is 3. 1 to the 1/2 is 1. That's 2. Number 33, we've got, that's an ugly looking thing, 1 to 3 x plus 2 over the square root of x squared plus 4x plus 7 dx. So I don't know why I wrote an equal sign there. So let's let u equal this thing inside the square root sign. And du would be 2x plus 4 dx. And 2x plus 4, I can get this to be 2x plus 4 if I multiply by 2, right? And I multiply by 1/2 on the outside. So 1/2 is the integral. My new u numbers, see, when I plug 1 in here, I get 1 plus 4 plus 7 is 12. And then 9 plus 7 is 16 plus 12 is 28. Did I do that right? Let's do that again. 9 plus 12 is 20. Yep, I think that's right. Okay, and then that gives me u to the minus 1, kind of like number 29. Right? So 1/2 times the antiderivative of u to the negative 1/2 is still 2u to the 1/2. Those cancel, and I get the square root of 28 minus the square root of 12. And I suppose you could simplify that if you want to. That would be equal to 2 square roots of 7 minus 2 square roots of 3. All right, what was that? 33. 3 more. 35. We have 0 to pi over 4 of 4 sine x cosine x. It's actually 2 different ways you can do this one. You could make the u equal to sine x or cosine x because they are the derivatives of each other, but for a negative sign. So if I let u equal sine x, du would be equal to cosine x dx, which I have. No, I don't really need that 4, so I'm just going to move that right to the outside. So 4, my new u numbers, the sine of 0 is 0. The sine of pi over 4 is the square root of 2 over 2. And then on the inside I just have u left, right? du. Well, antiderivative of u is u squared over 2. 0 to the square root of 2 over 2. I'm going to go ahead and take that, factor that 1/2 outside, which will make it 2 on the outside. So then I have u squared, square root of 2 over 2 squared minus 0 squared. Square root of 2 over 2 squared is 1/2 times 2 is 1. Number 30, oh, is 37 the next one? Wait, maybe it's, yeah, it is, 37. Of the integral from 0 to the square root of pi of 5x times the cosine of x squared dx. So this looks like could be the what's inside. Let u equal x squared. Du is equal to 2x dx. So I need a 2 here. I need a 1/2 on the outside, and I don't really want this 5 here, so I'll move that to the outside too. So on the outside I've got 5 halves. My new u numbers when I square these, 0 squared, square root of pi squared, and on the inside I have the cosine of u du. Now the antiderivative of cosine is sine. So 5 halves times the sine of pi is 0. minus the cosine of pi is 0. That. Guess this has 0 area there. Interesting. I'll have to check that, make sure that's right. And number 45, last one. So 45, I think this is the trickiest substitution here. Hopefully, by now, you have some pretty good calculus intuition. And maybe you might try a couple things that don't work. If you tried using this thing like what worked in a couple earlier problems, if you make the u equal to 4 minus 3x to the fourth, it doesn't work because you don't have some version of x to the third up here. So I don't know, you could try a couple things, but maybe at some point it occurs to you, thought bubble, maybe this is supposed to match up to some version of the derivative of the sine inverse function. Maybe I'm shooting for that. And if you think that that might be the case, notice here that if I am going to match it up to this, that this 1 here is not negotiable. So I would first have to factor the 4 out of the bottom of this. So doing a little scratch work over here, if you factor a 4 out of 4 minus 3x to the fourth, it would become 1 minus 3/4 x to the fourth. Right? And if you put that all under a square root sign, like it is, then the square root of 4 is just 2 times the square root of 1 minus 3/4 x to the fourth. So that means I could factor a 2 would come out of here, with leaving this behind. So that's the first thing I'm going to do. A 2 comes out of here, which is like a 2 coming out, like a 1/2 coming out, since the 2's in the denominator here, right? And then this would look like the square root of 1 minus 3/4 x to the fourth. And that's gotten me closer, because now I have the 1 where I need it to be. If it's going to match up to this, then I would like, whoops, there it is, I would like u squared to be equal to this. I'd like to turn this into u squared, 3/4 x to the fourth. And if that's what u squared is, then u would have to be equal to the square root of 3 over 2, well that looks kind of promising, times x squared, right? That's what the u would have to be. If you're wondering about the plus or minus, we don't have to because we're only dealing in positive numbers here. And then the du would be equal to, taking the derivative of that, would be the square root of 3 times x dx. So it looks like what I need here is I need a square root of 3 here. I've got the x, right, so that's good, which would mean I would need a 1 over the square root of 3 on the outside. Alright, so rewriting this now. I have 1 over 2 square roots of 3. My new u numbers, when I plug 0 into this, into this, I get 0. When I plug 1 into this, I get the square root of 3 over 2. And then on the inside, I have successfully substituted, so it did in fact turn into 1 over 1 minus u squared, or sorry, 1 over the square root of 1 minus u squared. And I know that the antiderivative of that is sine inverse u. Now 0 to the square root of 3 over 2. So almost there. That's 1 over 2 square roots of 3 times the sine inverse of the square root of 3 over 2 is pi over 3 minus the sine inverse of 0 is 0. So we get a final answer of pi over 6 square roots of 3. And I sure hope that's right, because I'm going to stop the video now and check my answers. So any problems, I guess it'll show up in the comments. Hope that was as fun for you as it was for me. Remember, speed is important here, right? So you want to practice these problems so you can get fast at them.